Thank you, everyone. It's wonderful to see you all here. My name is Daniel, and this talk is about a project that I had been working on for the past 3 years. It's called MIDI FX, and by the end of this talk, I hope um, you can see how it can be useful to you to implement your own custom MIDI setups, no matter how niche or how crazy your ideas are. I hope that you can uh, try to use this tool to solve your own problems. A bit about me. I'm a computer engineering student in my final year, and I picked up music production about 6 years ago. I was exposed to all of these plugins, EQs, reverb, the Fourier transform, and all of this stuff. It felt like magic to me. So I was like, I want to learn how to make these things on my own. I want to understand the magic behind all these tools that I was using. So that's what got me into audio development. Last year, I was accepted into the Google Summer of Code program, where I worked on the free and open source DJ software called Mix, and I improved its harmonic mixing workflow. Back to our project. To understand what MIDI FX is, we need to at least go over a base for what MIDI is. So on the left, you see a very familiar device. It's a, yeah, yeah, it's a MIDI keyboard. So over here, you have a MIDI keyboard. When you press a key on this keyboard, it's not going to generate sound on its own. It's instead going to send a message to the computer that, hey, this note was pressed and here's how loud it was pressed. Then when you release a note, it's going to send another message back to that computer. This device can also have knobs and sliders, and it needs to be able to send that information to the computer again. Then on the computer, you can use whatever sounds you want. You're not restricted to whatever comes with the keyboard. On the right, you have a more interesting device called an electronic wind instrument. The cool thing about it is when you play it, it's gonna sense how your breath is flowing, and it's gonna send that information to the computer. So you can use it to control flutes, an oboe, a piccolo, any other device. It can even change the fingering mode. So with one device, you can control many different wind instruments, which is quite powerful. And I wanted to show you that you don't necessarily need a computer. You can connect a MIDI keyboard directly to a lot of analog synthesizers. So MIDI has to be a protocol that is simple enough that you can use it even without any digital computers. So MIDI, it stands for Musical Instrument Digital Interface, and it is the standard language that's used by all kinds of manufacturers, whether it's Yamaha, Roland, anything. They use MIDI for sending information between other devices. And you might also know that you can record MIDI data into MIDI files, and then you can play it back. Now, MIDI data is sent in the form of messages. So in the next slide, I'm going to show you what a message looks like. Most messages have 3 bytes, so 3 numbers. They're called status, data1, and data2. Status tells us what kind of message this is. Is it a note on event? Is it a note off event? Is it a knob that's been turned? Is it something else? Then the meaning of data1 and data2 changes based on what status is. If status is a note on event, data1 will be which note it is. Data2 will be how loud that note is. If status is a control change, which means a knob or a slider or something like that, then data1 will be which control is it. Data2 will be what's the current position of that control. MIDI also has this feature called channels, which means through a single MIDI line, you can send information for up to 16 channels. And that information is also encoded into the status byte. Now we come to MIDI FX. So it's a program that it's used for manipulating MIDI information, and it does that by using a node-based architecture. You can have a single node that does something very simple, like it might delay the MIDI information, or it might transpose the note that's being played. and you can combine these nodes together to create something very complex. In addition, MIDI FX runs in the browser. This means that you can leverage browser APIs to you can interact with MIDI and the browser API. So you could, for example, send MIDI through the internet. We have a few demos to show that, and yeah, let's just get straight into the demos now. So the first demo, um, over here I have an external input node. That's my MIDI keyboard, and the external output node is my DAW. So I just connect them, and then I can play. Nothing surprising here. We are just sending MIDI through MIDI FX. But now I've added a delay node. What's going to happen is as I play on the keyboard, the raw MIDI signal is going to go to the DAW, but another copy of the MIDI signal is going to be delayed and sent back to the DAW. Now we're going to add another node called the transpose. You might be familiar with this function. It's just going to change the delayed node. So in this case, I've transposed the delayed signal by 2 semitones. And you can even change these values. So I like to use 7 semitones, a fifth. Then you can even scale the velocity of these notes so that the delayed signal is a little bit quieter. Cool. So that's like how MIDI FX works at its core. You have all these different nodes and then you can connect them together. Now I want to show you another demo, which is the hand tracker. It looks something, I've set it up in this way, where I have the hand tracker node in the middle, and on the 4 sides I've kept other nodes. These are called control change visualizers. They can see what is the value of a knob or any control that's being changed. So what this node is going to do is it's going to look at my hand through the camera, and then based on what my hand is doing, it's going to change some kind of control value. For example, if I open and close my hand, I've set it to change the cutoff of a synth. If I move my hand front and back, that's set up to change the timbre from a saw wave to a square wave. Then I also use my other hand to change the attack and the ADSR curve. So let's have a listen to that. Yeah. So the way the hand tracker is able to tell what my hand is doing is I use a library called media pipe, and it looks at your camera feed and it will give me points for wherever my joints are located. Then once I have that information, I can use some vector math to figure out what my hand is doing. For example, over here, to detect whether my hand is open or closed, I'm using a dot product. So if you see on the left, I'm making 2 vectors for uh, my knuckles. So I'm taking these 2 points and making a vector out of it. I'm taking these 2 points, making another vector out of it. The dot product is an operation that tells us how aligned 2 vectors are. So if they're both pointing in the same direction, the dot product is going to be very high, and I'm going to know that my hand is probably open. If I bend my finger, as you see on the right, my dot product is going to be much lower. So that's how I know that my finger is probably closed. So do that over every joint of your hand, and you figure out whether your hand is open or closed. So that's kind of how you can use some vector math to figure out what the hand is doing. The next demo is with an Arduino. I was quite happy to see that a lot of you are into electronics, and MIDI FX can be used with any serial device, including an Arduino. So over here, here's what an Arduino looks like. It's an Arduino Uno, and on both of its sides, you have a lot of pins to which you can connect different things. And around this Arduino, I've put just a very small subset of things that you could connect it with. So on the top left, we have an ultrasonic distance sensor. Below that, we have an infrared sensor, which is used a lot in line following robots. Below that is a pressure sensor, a force sensor. And I believe this is what's used in a lot of MIDI controllers, which can detect how hard you're pressing a button or a keypad. Below that is a camera. You can connect a camera to this thing. On the right, we have some output devices. We have an LCD display. You can connect a speaker with it. You might want to use some amplification, but it works. You can connect LEDs. The golden thing, that's a piezoelectric buzzer. It's the thing that makes the beeping sound in our watches. And every speaker is a microphone, so this thing can also be used as a contact mic. On the bottom right corner, the blue thing, that's a servo motor. It's a motor that moves 180 degrees, and you can control exactly what angle it's moving at. And that's useful for robotic arms and things like that. So for our demo, I've used the ultrasonic sensor, the one at the top left. This device, here's how I set it up. So this device, it has a transmitter and a receiver, but it works in the ultrasound range. What it does is it sends an ultrasound signal, and as soon as there's some object, that signal is going to bounce back, and it's going to be received by the ultrasonic receiver. We can measure the time delay between the transmission and when we receive the signal back, and we can figure out how far the object is. So let's see how that works out. So I did flip the control values inside the door so that as my hand is closer, the sound gets louder, because I felt that was more intuitive. But yeah, over here it does show that the value is lower when my hand is closed. Now the next demo, okay, yeah. As for how you would send information from the Arduino to MIDI FX, it's as if the Arduino was a MIDI device itself. You can just serial.write the MIDI bytes. You can, for example, for sending a control change message, you just write the status byte, then the data 1 byte and the data 2 byte, and MIDI FX picks it up. Now, for the next demo, MIDI over internet. Now, when you do something like this, you really are concerned about latency. We want the latency to be as low as possible. So the way we achieve this with MIDI FX is we use a protocol called WebRTC, or Web Real-Time Communication. It's used for mainly for video calls and stuff. It's used by Discord, for example. And what's special about it is that once the two devices have established a connection, the data transfers between them directly. You don't need a third intermediary server. The way it works is first we have a, a broker server. In this case, it's called peer server. What's happening is client A is going to tell peer server that, hey, I'm client A, this is my IP address, these are the ports I'm willing to connect with someone else to. Then client B does the same thing. Then client A says, hey, I want to connect to client B. Can you give me its IP address and port? Then peer servers, since client B has said that it's willing to connect with someone, peer server is going to give that information to client A, and then client A can establish a direct connection with client B, and the peer server is not required anymore. So the reason I call the intermediary server peer server is because I'm using a library that simplifies the WebRTC protocol called PHAS, and it just takes away all of the under the hood mechanic stuff. So you just focus on making a good product. So let's see a demo for that. So over here I have my phone on the right and my laptop on the left, and you can see I've given each of them an ID. So my laptop has Dan laptop, my phone has Dan phone, and then I'm gonna connect to peer server and say that, hey, I wanna be ready for establishing a connection. And after that, I'm gonna put the ID of my phone on from my laptop. So I'm establishing a connection from my laptop to my phone. Now I'm able to send data between the two. So initially I'm sending data from my phone, yeah, from my phone to my laptop, but I can even send information the other way around. So in this case, I'm going to be playing from my MIDI keyboard, which goes to the laptop, which goes through the internet to my phone. And I have a little node at the bottom here called the chord explorer. It tells me what chord I'm playing. So yeah, that's a C major. The way I actually use it in practice is I have my keyboard over here, I have my laptop over there. I can't see my laptop when I'm playing the keyboard, so I'm going to take my phone, keep it in front of me, and then when I play the keyboard, I can see what I'm actually playing, which chord I'm playing, things like that. So the power of MIDI FX is really in combining different things together. So yeah, I just finished the demo. Yeah. So one thing I want to show is maybe the nodes that are available aren't enough. Maybe you want to implement something of your own. So I just wanted to give you a peek under the hood of what a node looks like, because MIDI FX is open source. So if you want to build something, if you want to add something on your own, you can do that. So this is a transpose node. It's a very simple example. When you give any MIDI signal to it, it's gonna check whether this is a node on off message. If it is, then it's gonna transpose it up or down. So mainly there are three things that are going on. You have an export called input, and yeah, I just want to open MIDI FX itself so you can kind of see what things look like. So here's the actual app. So if you look at MIDI FX, you have the inputs over here, you have outputs over here. Some nodes, they can have multiple outputs as well. For example, this is the node splitter, which will split node on and node off messages into separate streams. So that's the reason why inputs is an object. You can have an input called MIDI. You can have another input for something else. Now, every input is actually just a function that takes in 3 bytes, the status data1, data2 bytes from MIDI. Then we just check, is this a node on off message using the status byte? If it is, we figure out what's the transposed node by just taking the node that was supplied to us and by figuring out what is the transpose value, which is stored as a state variable. Then we emit the transpose node to whatever outputs are connected. So in this case, the output is also called MIDI. It's this thing over here. And you can see that's defined in the outputs. If it's not a node on-off message, then we simply emit the MIDI message as it is. As for outputs, you just define it and then you use new set because that's something that's relevant under the hood, every output is actually a set of input functions. So it's the way it works is like when I connect this thing to this thing, this input function goes into the set of this output node. So that's why it's used, but you usually don't have to mess with that. State, that's a variable that's an export that stores the state, whatever parameters you want. And what's cool is this information gets stored in preset files and also in the local state of MIDI FX, because you don't always want to recreate the setup that you just made. Now, what's next for MIDI FX? Right now, I'm working on making UX improvements. I'm working on making it easier to use, because when I started it out, it was just an idea like, what if we could, would this thing even work? But now that it did work, I want more people to be able to use it. So I want to make it user friendly. And if you have any feedback on how I could do that, that's very welcome. I'm also working on upgrading to Svelte 5. MIDI FX is based on a web framework called Svelte. It's one of the most loved frameworks in the JavaScript land. If you haven't heard of it, it's basically HTML, CSS, JavaScript, the core web languages, with a little bit of extra syntax added on top of it, so that these three things, they work together very nicely. And lastly, I do want to build a community around MIDI FX, because of its modular nature. I feel that the more minds we have working on it, the more we can explore what we could really build. So with that, I want to say it's been a fun time talking to all of you. And yeah, thank you for listening to my talk.
Yeah, I think we have some time to take some questions. So, any thoughts? Yeah.
Hey Daniel, nice presentation.
Thank
Very
you.
impressive work.
Thank you.
So the MIDI over internet, how real time it is? Did you try to measure the latency over there?
So it depends on several things. For example, if I'm sending the data within my room, then the latency is going to be quite low, because it's going to go from my laptop to my router, possibly to my ISP, but I don't think it's going that far, because it feels so instantaneous that I doubt that it's going too far from my house. But it's probably not going too far and then it's coming back to my house. But if I'm transmitting signals from India to maybe my friend in America, then obviously the latency is going to be a lot higher, right? So it's related to the latency of WebRTC itself. Yeah, but as for the options we had, I feel like this was the most the lowest latency option that we could use in the web browser.
Amazing. Any other questions? All right. Again, round of applause for Daniel for such an amazing talk.
Thank you.